in one direction, and it's going to push me in the other direction with an equal and opposite force. All right, let me get ready here. Oh, yes. Oh, yeah. Yeah.
It's on 911, right?
Oh, I remember that.
Okay. This thing gets heavier every year. I should remind you, as I said, this is a 50-pound fire extinguisher, and I am 59, and these are roller skates. If you look on it, you pick one of those things up, there's a little pin in there, just like a hand grenade has a pin. And it keeps it from firing. And if you pick it up and you grab it by the handle, it starts shooting off. I used to demonstrate where I go around in a circle. And once I sort of lost my grip on it, and I could hold on to it by the handle, which is like holding onto a machine gun by the trigger. And all I could do is spiral into a slump onto the floor. Okay. Now, also, when I first did that demonstration, oh yes, I can tell the story while I'm taking my shoes off. When I first did that demonstration, I had a little fire extinguisher. There was a rugged floor in the building I was doing it in, and I had an old pair of skates. And I tried it, and nothing happened. And I got so angry, I came back the very next time with a new pair of racing skates, a 50-pound fire extinguisher. But of course, there was still the rugged floor. Well, you know how you can plot, we like to plot things in physics. You plot common sense on this axis, and you plot time on the years on this axis. You know, you're born and things are really going well, you learn how to eat and sleep and all that sort of stuff. Then hormones kick in, you have a dip. Other things go on. But at some point over here in my teaching career, it went to dead zero. Because to get off the rug floor, I got up on the table. And I discovered that if I held it a little bit off center, I could rope myself off that table, translating and rotating at the same time. The force that this thing exerts, especially at the initial shot, is an extremely dangerous amount of force. The reason the regular fireman doesn't experience this is that there is a safety device that splits the stream into two parts where the forces cancel each other on a real fire extinguisher. So there's no recoil on a real fire extinguisher. Okay, rotational motion. Now, I'm going to do rotational motion a little bit shorter than usual, so we have some time to do some other things later. But I do want to go over a few of the simple things. If I have something that rotates, I have trouble remembering clockwise and counterclockwise. So if I rotate it like this, I curl my fingers in the direction of rotation. And if my thumb points up, that's thumbs up rotation. I go like this, that's thumbs down rotation. And those are the only two ways I can rotate if I keep one axis. And so now what I'm going to do is I'm going to do the same sort of thing I did with the fire extinguisher, except I'm going to shoot this with thumbs up rotation, and it's going to shoot me with thumbs down rotation in the opposite direction. So I'm going to sit here and turn this guy, and I spin him, and he spins me, but unlike the fire extinguisher, I can stop him, and he stops me. Okay? So that's... by the way, this is a lead-weighted wheel, which is why it's a little difficult sometimes. Okay, the other thing that's cute is if you spin this guy like this, and you give him a thumbs down up rotation. Now, of course, all of you guys are now spinning with thumbs down rotation because my foot's on the floor and the whole earth is compensating for it. If I pick my foot up, I have an initial thumbs up rotation. I reverse this guy, and it has to do twice as much to me. If I put him back, he puts me back. We have a wonderful little physics demonstration facility at the Math and Science Learning Center across the street here, where you can play with a lot of these sorts of toys. The other thing I wanted to make sure I emphasized on rotation, there was one thing before that. Even before I did this, you notice the way I spun it up was to go like this. There's two types of pushes. Remember, I did a push and something moved? I can push on this guy very hard, and if the line of action of the push goes through the axis of rotation, nothing happens. But if I go not along the axis of rotation, I can then make it rotate very easily. Okay, so that's one thing, I should have mentioned that earlier. Now the next thing I want to emphasize on rotational motion is that how much mass is how far from the axis of rotation is really crucial. If you have lots of mass far from the axis of rotation, it's hard to get something rotating. If it's close to the axis of rotation, it's easy to rotate. And if you're an isolated system and you're rotating, then the state of the system stays the same. And yeah, Dave, watch out. We don't want to lose you. I'm expendable, but let me just check out my